Swayam Prabha. Digital India. Educated India.
This maritime engineering, as you see, is a very special program which has got multidisciplinary input from mechanical, civil, structural, aerospace, naval architecture, chemical engineering, electrical, electronics, applied mechanics. It's a multidisciplinary program. You will find this program is completely different, dedicated to industrial training and thorough capacity building on the new trade of maritime sector. It's a grooming economy which will give you a lot of job opportunities and research frontiers as far as India is growing. And the Blue Corridor effect, which is planned by Government of India, is one of the important mission which requires maritime engineering growth to happen in the country. So this program caters to expected that capacity building in this program.
Friends, this is part of a material science engineering laboratory which becomes one of the teaching aid for the maritime engineering program. So when you talk about materials innovation in maritime industry, though concrete and steel have been conventional candidates of choice for engineers, for example, we have titanium vessels, high-speed craft boats made of fiberglass. These are all advanced materials which actually do not come across conventional standard design code of practices. We conduct box furnace test, tube furnace test, vacuum arc melting, induction melting, vacuum induction melting, vacuum sealing unit, which are all present in this laboratory is a small segment of material science laboratory. Friends, a typical furnace where the operating temperature for testing specimen can go as high as 12 degrees Celsius. Generally at room temperatures and ambient condition, the mechanical properties will not alter much. As you see in the course lectures, you will notice that strength of the material get degraded when the temperature rises beyond 600. Therefore, when you talk about fire resistant design, you must also choose an alloying element such a manner that the strength doesn't degrade beyond 600 degrees Celsius at all. Welcome to the ambience of IIT Gandhinagar Lecture Theatre. This is one of the interesting classrooms where the maritime engineering classes will be conducted. We have got state-of-the-art projection facility and good audio-visual recording systems. Once the lecture is over, you see the system here. We can generate the PDF files of the lecture directly and you can email the PDF files directly to your email IDs. So it's a state-of-the-art facility we have in IIT Gandhinagar where the lectures are lifetime recorded and shared with the students immediately. This is the IIT Gandhinagar library. This has got all collections of books which are referred as the standard textbooks and references for the course and the program. It also has lot of online editions of design code of practices and reference materials and e-collections of various video lectures of international courses and programs related to maritime engineering. We will be taking you around to the advanced material manufacturing units. So you will have state-of-the-art facilities available at IIT Gandhinagar. So welcome to the program to join MTech and PhD at IIT Gandhinagar Maritime Engineering. So please try to enjoy and take the advantage of this to the maximum. Welcome to the program and welcome to IIT Gandhinagar. Friends, welcome to the 14th lecture on the course Maritime Structures, Types, Construction, Pre-Service Analysis and Design, offered by the Department of Maritime Engineering at IIT Gandhinagar. In this lecture, we are going to see what special applications are required to choose materials for maritime construction. So, this is a series of lectures where we will discuss more in detail about different kinds of materials, starting from the basic properties that are required for a material to be used in maritime construction, then specific material properties which are classified by different international codes for maritime applications and so on. So, in this lecture, friends, lecture 14, we welcome you to understand basic properties of material which makes them suitable for maritime applications. This lecture has got couple of references which I would urge you to go through, because they will be covering from different aspects of textbooks. fire resistant design of structures by CRC, design aids for offshore topside platforms under special loads by CRC, offshore complaint platforms, analysis, design and experimental studies by Wiley, dynamic analysis and design of offshore structures by Springer, design aids of offshore structures under special loads including fire by Springer, risk and reliability assessment of offshore structures by CRC, ocean structures and materials by CRC, advanced marine structures by CRC, fundamentals of offshore engineering by CRC. All these books are authored by me along with eminent personalities of international repute in different books. Please have a look of these contents of the books for self-learning and improve your reinforced knowledge and skills in this particular context of the course. Let us ask a question. What is speciality about choosing material for maritime structures? Why material choice should be done more carefully when you start constructing maritime structures? Maritime structures are constructed for various applications. We already know that: oil and gas exploration, wave and wind energy harvest, coastal protection, repair, inspection and regular maintenance. Friends, as we now know, maritime structures attract huge capital investment and they are essentially of strategic importance. We also understood to some extent that the geometric form governs the design more than the functionality. Material properties, environmental context and technological advancements also govern the design. However, it is very important for you to note that the downtime of these kind of structures, whether you do this downtime for maintenance or repair or rehabilitation or strengthening, downtime of maritime structure could cause a huge financial loss. So, you cannot stop operation of a maritime structure, be it a port or a harbor, a coastal protection system or an offshore platform. Operation cannot be suspended because that can lead to huge economical losses. If you are conducting repair or strengthening of any one of the structural members as part of the construction program involved in the maritime industry, you cannot redo this repeatedly. A repeated intervention, even in the visibility of maintaining the functionality, is not desirable. You should do a periodic maintenance so that serious structural interventions do not disturb the functional aspect of maritime structures. So, therefore, friends, to have a periodic well scheduled maintenance program, continuous monitoring becomes vital. So, obviously, all these points I will try to relate it to the material choice. That is the idea why we are projecting these points in this slide, so that we will now connect the importance of these points slowly and gradually to material choice. Maritime structures demand preventive maintenance while the system is in operation. Generally, friends, you could have noticed or heard or seen that structures are repaired only when they are non-functional, whereas maritime structures will remain functional when they are getting repaired, and they are also subjected to the minimum environmental loads present in the sea state when they are under repair. So, that is very important. Have you ever heard of a structural system which is getting repaired when being loaded? Generally, when you repair a system, you offload the system loading. You do not do loading of the system at all, is it not? You keep it in an ideal state and then do repair. Whereas in maritime structures, this is practically impossible. Wave and wind forces will always be omnipresent in maritime structures. So, their direction, their amplitude, their dynamic action, their force amplification cannot be predicted because they are weather dependent. Obviously, you cannot prepare or plan a weather window in a maritime structure repair so that the sea state or the sea loads or the wave loads are minimum. You cannot do it. So, it is always a complex problem where you start repairing a structural system in maritime industry and the maritime industry or the structure receives the maximum load unfortunately during that time and the repair becomes inefficient. So, therefore, friends, these structures demand preventive maintenance when the system remains functional. Structural repairs must be carried out without shutting down their operation. That is very important because you cannot afford to shut down a maritime structure operation even for a single day, because they are strategic importance and they are also involved in revenue generation like offshore platforms. You cannot shut down the working of a platform at all. Most importantly, friends, these structures need to be repaired when they are loaded. Generally, when the structure becomes lesser in strength, loading has got to be relieved. Okay. But unfortunately, maritime structures, loading will remain unchanged. You have to strengthen the structure with the existing loading, which is getting accelerated, which is getting improved day by day because of weather conditions. So, these structures need to be repaired when they are loaded. Therefore, the structural forms must be simple, easy to inspect and maintain. That is the key word here. So, the structural geometry of maritime structure should be simple, easy to inspect and carry out repair and maintenance. Okay, that is very important to learn because this is a very special requirement. Maritime structures alone have it. Maritime structures operate under high risk factors due to exploration and production processes. We already saw in oil and gas exploration, hydrocarbons are involved and they are considered to be high class explosives. Okay. Therefore, the failure of these kind of structures may lead to serious environmental pollution and economic losses. So, we cannot afford to have a failure of a maritime structure. Friends, to avoid serious consequences, it is better to follow a preventive maintenance approach which depends on continuous monitoring under time varying loads. So, generally friends, maritime structures repair and maintenance is planned on a periodic basis at regular intervals. Okay, that is very important. It is a periodic system schedule which is deployed to carry out preventive maintenance. And of course, this depends on continuous monitoring of the system. You have to do a health monitoring of the structural system for years to collect the data according to the behavior expressed by the results taken from the data or processed from the data. One has got to plan the preventive maintenance so that the structural strength does not get degraded. The basic knowledge about materials used for repair, construction and maintenance becomes very important because that will help you to choose appropriate material for construction. So, friends, it is very important that choice of material should be done in such a manner that the intervention is done only for a shorter time. I can give a very simple example. Let us say we have something called rapid hardening cement. We have also called quick setting cement, which you must have heard. When you use underwater construction possibly and you are going for a repair of a structural system, which cannot hold the repair for a longer time, then one can always think about using special kind of cements which can be used for repairing their concrete structures. So, I am giving a very simple example, not necessarily you should use RHE and quick setting cement, but however, these are some classical applications which comes to the mind directly. So, most of the chemicals being used for repair and rehabilitation, or I should say chemical admixtures being used for repair and maintenance essentially come from different categories of basic materials. So, the knowledge of basic material is very useful and essential to carry out periodic maintenance of maritime structures. Okay. Let us look at this flow chart. What are the possible materials I can have for construction? Let us have a general question, out of which then we will choose which are applicable and useful for maritime application. Material is a big subset which can be used in different forms. Okay. You can have metals, you can have wood, you can have plastics, you can have textile materials, fabrics, geosynthetic is a fabric. You can have environmental friendly material, you can have thermoplastic resins and so on. When you talk about metals, you can have ferrous and non-ferrous metals. When you talk about ferrous classification of metals as materials, you can have mild steel, stainless steel and wrought iron, whereas non-ferrous could be copper, aluminum, brass. So, this chart helps you understand different categories of materials which are all useful for construction in general, out of which all of them may not be suitable for maritime environment. So, material properties should be assessed under specific application of environmental and loading conditions. You cannot choose all material available in the literature to construct maritime structures. Maritime structures have special application requirements under environmental and loading conditions. The maritime environment also exerts other material forces. In addition to the dead and live loads, it induces chemical, fatigue, stress effects and corrosion effects onto the member of the material of the structure. Therefore, few basic properties of the material are required apart from the strength requirements. Okay, what are those few basic properties? Let me list them here for our convenience. The foremost should be survivability, under worst failure scenario. The material what you choose for maritime construction should be survivable under worst failure scenario. The second could be it should have enough strength to withstand accidents. Collision accidents are all integral part of maritime structure, you cannot avoid them. Okay? But the material should have enough strength to resist those kind of shock and vibration and absorption loads coming on the structure. Thirdly, it should have capability to withstand excessive loads without failure. Friends, even the lecture is focusing on kind of materials alone, we are trying to look at the application of this and specific sector in maritime industry. The material what you choose for maritime construction should be capable to withstand even excessive loads without failure. That is very important, though every metal has a capability to withstand the loads beyond which it will give away, but still we have to look into the possible maximum exploitation of the material to withstand excessive loads without failure. It should not fail. It should sustain worst environmental condition like hurricane, high sea tides, etc. Worst environmental conditions it should be able to sustain. So, the material should withstand these kind of additional forces. So, the choice of material, though you have got wide variety, does not fit with all requirements, because there are specific requirements for which a material should fulfill before being chosen for maritime application. Having said this, there are few other factors which will also govern the choice of the material for maritime application. They are physical and chemical properties of material, cost is another factor, fabrication facilities is another factor, and expected maintenance cycle cost is another factor. The physical and chemical properties of material, the cost and expected maintenance schedule will all line up to add cost to the overall project. Therefore, it is very important also to ascertain that material should not be allowed to fail. So, they should be chosen to avoid sudden failure. So, what does it mean? Essentially, I am looking for material which are elastic in nature. I do not want brittle material. Okay, I do not want. I want ductile material which is able to withstand the forces with enough warning. The material should avoid catastrophic or let us say sudden failure. It should give warning before fail. That is possible only the material is ductile. So, by this we can easily narrow down to one class of material which is steel. Friends, however, the design requirements become important for structural members of maritime structures. Besides meeting the design requirement, they should also withstand operational hazards. Okay. When we are fabricating the structural geometry, you are loading, towing, appending, commissioning, fixing, welding, laying, lifting. So, one has got to withstand all these unforeseen forces during maintenance or during construction, commissioning, etc., and they would have capacity to withstand these hazards, including operational error. Okay. So, having said this, let us see what are those most important characteristics of a material to be chosen for maritime application. Most important, because there are many geometric properties and structural properties of material. We will see a few of them which are very critically important. The foremost one is the yield strength. Okay. It is a yield strength. Yield strength basic values required, for example, let us say 350 megapascal. Basic value. A steel having yield strength lesser than this cannot be used. So, who will guide me this value? It is very interesting that we have to refer to the international standards, the codes of practice, which will help us to choose material with minimum yield strength. Second property which is vital is Young's modulus, because as I said, we are talking about large floating structures which experience large deformations. Therefore, I am requiring a material which will result up in less deflections and bending. So, Young's modulus is also another catch of selection of material. The third of course could be the Poisson's ratio, and the fourth one is the fatigue performance and fatigue resistance. So, friends, if I can chalk out the summary saying what are the important characteristics of material, I should say the foremost one is of course undoubtedly is the yield strength. The second one could be the modulus of elasticity. For example, steel has a modulus of 2.1 10 power 5 Newton per mm square, or one can say 210 gigapascal. Let us convert this gigapascal 210 into 10 power 9 Newton per meter square, which is 210 into 10 power 9 by meter square millimeter square. So, it is 210 10 power 3 or 2.1 10 power 5 Newton per mm square. So, the important property is Young's modulus. The third one, which is also equally important, is the Poisson's ratio, which we know is lateral strain by longitudinal strain, is Poisson's ratio. So, when we subject a body to biaxial stress state, this property gets invoked. The fourth property, which is essential for the material to remain in marine structure, is a better fatigue performance. There are many materials, engineering materials, which cannot sustain cyclic loading. They are very bad indicators in fatigue performance. So, I am looking for a material which has got good yield strength, good ductility and good Poisson's ratio, and it should be able to withstand fatigue, reversal of loads under given safe threshold number. So, mechanical properties of the material reflect the capacity to resist the various types of loads. Some of the important mechanical characteristics are, let us mark them here: strength, hardness, elasticity, plasticity, brittleness, ductility and malleability. These are vital structural properties of material used in maritime structures, and they should be looked into very close before they are chosen. You cannot simply say I will choose steel because steel has got good elastic modulus and good yield strength. Steel may not be a good performer in malleability and ductility depending upon its constituent materials. So, these properties may be described in terms of forces or stresses to withstand and how they are resisted. The common types of stress which is occurring on maritime structure are compressive, tensile, shear, torsion, impact and a combination of these such as fatigue. So, the design of structural systems for maritime structures deals with different forces and actions coming or arising from the environmental loads. So, one can ask me a question, what should be the fundamental guiding parameter to choose a material for maritime industry? Strength is the fundamental parameter. Strength of course, the property of the material enabling the material to resist deformation under load. The second property desired for maritime structure is ultimate strength. Ultimate strength corresponds to the maximum strain that the material can withstand. Some materials are equally strong in tension and compression. I can draw this figure. Let us say I can draw the origin. Then let me try to draw small portion below this is the yield or the elastic limit. let us say elastic limit, and this becomes my yield point, this becomes our breaking point, stress ultimate. And now if I try to draw the vertical arm, not elastic but at yield, I will pick up these two stress values because it is stress strain curve. So, let us say sigma 1 and sigma 2 are known to me, can pick up these two stress values, okay, and I can always check what is the ductility availability between these two values. Common types of stresses which are subjected to offshore structures or maritime structures are compression, tension, shear, torsion, impact, and combination of these. So, under these, strength becomes the ultimate priority to resist deformation. Ultimate strength corresponds to maximum strain, which is also required to be considered for the design. Some materials are equally strong in compression and tension. So, if I draw this as tension side, so I can extend this figure on the compression side also, it becomes identical, mirror reflection. So, this is the compression test and this tension test. Okay. Usually we consider only this part for analysis, but generally we want also material exhibit the same behavior or similar behavior. That is, if this is sigma y, this is also sigma y. They are identical, same. Okay. Similarly, this is sigma u, this is also sigma u. They are same. So, the material has same property in tension as well as in compression, which is desired for maritime structures. But some material have a marked difference. Take for example cured concrete. The maximum strength is 50 megapascal in compression, but in tension is only 3. Take carbon steel. The maximum strength is 400 megapascal in tension and compression, but maximum shear strength is only 290 megapascal. So, depending upon the type of load applied and examined, the strength on the respective behavior changes. We are looking for a material which exhibits these properties like high strength, high ultimate strength, and good ductility and good strength equally in all, which is a very rare application, I know that, but still there are material classified based on this. Okay. Therefore, friends, very importantly, if you want to deal with the material selection, dealing with maximum strength alone, it is not always necessary to state the type of loading. Okay. The type of loading, because you know tension compression has a different meaning. So, type of loading also becomes important if you want to establish the same strength both in tension and compression, whereas different materials like concrete, carbon steel exhibit difference in compression, tension and shear. Having said this, few material properties which are basics are essentially important for choosing them for maritime application. The material that is stressed repeatedly under reversal of stresses is called a critical section. Stress at the critical section at the time of failure is definitely lower than its material strength to the maximum. Hence, in fatigue failure, magnitude of load is not important, but the number of cycles causing that failure is important. So, in S&N curve, amplitude stress is okay, but the number of cycles causing this is also equally important. Into this context, let us see what is hardness. Hardness is ability to resist permanent indentation. There are several methods by which can express hardness. For example, Rockwell hardness, Brinell hardness, Vickers hardness, etc. These are some of the methods devised and named after certain people to conduct hardness test. However, in maritime industry, we choose material based on Rockwell hardness test. It is commonly used in maritime engineering. The second property is toughness. Toughness is considered as a combination of strength and plasticity. When the material is subjected to a load of known magnitude, it causes deformation to the member. Elasticity is the ability of the material to regain its original shape and size upon removal of load. It is therefore the limit of the material up to which the material can be loaded. If you cross this limit, then the material will enter into non-linear zone of behavior. Okay? For example, if I have a stress strain curve of steel which looks like this. So, till this part it is elastic. You keep on applying the load, the deformation increases. When you stop load, it follows the same path. It is true till here. We call this apex point as yield point. Okay? Beyond this, if we increase the load, then the system exhibits non-linearity. Okay? So, one should also understand that elasticity is the ability of the material to withstand load or regain its original shape and size upon removal of load. Plasticity, on the other hand, is the ability to deform permanently without causing failure. So, the material should not fail abruptly, but it should give me sufficient warning, and plasticity is that ability to deform permanently without breaking. So, therefore, friends, by carefully alloying them, by carefully alloying the metals, one can always check the combination of plasticity and strength which is being, let us say, moderated, which is being played around to improve upon the alloying elements to form a better combination which can be used in maritime sector, what we call as marine grade steel. So, we come out with a new type of grade which is called marine grade steel, which comprise of special alloying elements which are useful, which can address all these properties in a better manner. So, friends, as a summary, in this lecture, we learnt about basic properties of materials. We have also understood why special properties are required of materials are required to be employed or to be used in maritime industry. Certain important properties which are yield strength, modulus of elasticity, Poisson's ratio are considered to be very important indicators to choose material for maritime application. So, friends, should you have any doubt or questions, please read for additional learning these books which is suggested. For example, I will recommend this book as one of the basic textbook for this at the time being for this chapter, for this lesson of lecture, because this talks about materials in a very large context. You will find it very useful, and you will also reinforce your learning by referring to this textbook, which may be available in an institution or in your consulting industry library. So, friends, this lecture spoke about the basic properties of metals or materials used for maritime industry. We talked about important properties, and we also learned what are those which will govern the choice of material for maritime application. Thank you very much. Namaste.